This is the example of a pendulum that is moving in a vertical plane with a velocity of 6 meters per second when theta is equal to 0. I need to determine the angle U where the tension in the cord becomes 0. Right. So I need to find, guys, the angle where the tension in the cord becomes 0, which means, guys, I need to find a relation between the tension in terms of theta. If I know the relation between the tension in terms of theta, I can find out the angle at which this tension is equal to 0. I have to do the free body diagram on this pendulum, right? So what are the forces? This is the weight. This is the tension T at any theta. And of course, I also have that the normal is in this direction. So this is a N, and this is the tangential acceleration. In fact, this is the tangential acceleration. All right, why is this the tangential acceleration? Because as you can see, it is moving in this direction. Okay, so now, guys, I have the angle between this x-axis and this t is theta, and this means that the angle between W and a tangential is also theta. So this will be theta. Always, guys, use the perpendicular line theory. Right? So if W is perpendicular to this line and this line is perpendicular to this line, then they have the same intersected angles. All right? So now what I can do is to find the sum of forces in normal direction. Sum of Fn is equal to MAN, which means what are the forces in normal direction in terms of theta? I know that W sine theta plus T is equal to mv squared over r. Right? So this is the normal direction. This is the tension. It is in plus T. If I do the projection of W on this one, would be W sine theta plus T is equal to mv squared. And now, if I do sum of Ft is equal to MAT, then this will give me what? It will give me that minus W cosine theta is equal to MAT. Okay. So I have this equation that relates AT with cosine theta. And I have, in fact, this equation, all right, that relates the sine with T. Okay, guys? So what should I do now? What should I do? My objective, guys, look, what are the unknowns in these two equations? I need to find T in terms of theta, okay? V is not given. It is only given when theta is equal to 0. So I don't know V, in fact. So V is not known. But I can find what is AT in terms of theta. So what I should do is to find a third equation that relates V, A, and theta. So I need, guys, to find a third equation that relates V, A, T, and theta. Because in fact, guys, if I know this equation, I can find out what is the tension from this equation. So guys, in fact, what should I use? I should use the kinematics equations. And this equation should be independent of time because I don't have the time. I have theta. All right. So what is this equation? It is V dV is equal to A tangential ds. And don't forget, guys, that ds is what? Is r d theta. Okay? Which means if I do the integration, v squared minus v0 squared over 2 will be equal to the integration, r is constant, so I'm going to put it outside the integration, of at d theta between 0 and theta, right? I know v0 squared, it is given, right? I know v0 squared, it is given when theta is equal to 0. So this v0 squared is given. I should replace at by what? By its equation in terms of theta given from this equation right here. So at is equal to minus w cosine theta over m. W is mg, so if I simplify by g, I'm going to have it is minus g cosine theta, all right? So this is at. It is minus gravity cosine theta d theta. So what is the integration of cosine theta? Because g is always constant, it is in fact equal to r sine rg sine theta minus sine 0, which is 0, so rg sine theta. All right? So this means that v squared is equal to 2 rg sine theta plus 2 v0 squared. Now that I know v squared, I can find what is an, right? So an now is known. Whenever I know an, I can find the tension, all right? So don't forget, guys, that the tension is equal from the second equation. It is equal to mv squared over r minus w sine theta. So now, guys, that I know what is v squared, it is 2r sine theta plus 2v0 squared. You can replace it here. Then you can find t in terms of theta. Then you can say t is equal to 0, and then you can find theta. All right, guys? All right? So I have to substitute this v squared by this equation. I can find the equation of tension in terms of theta. Now I can find what is theta at which t is equal to 0. Right? T is equal to 0 means what is theta at which this light rope is broke, right? It's broken. So whenever this light rope is broken, then there is no T, okay? So I need to find what is theta at which T is equal to 0.